So we have seen in molecular orbital theory that when two atomic orbital combine together to form two molecular orbit, and well, one is bonding orbital, one is bonding orbital, and the other one is anti-bonding orbital. And the anti-bonding orbital always have higher energy. Anti-bonding orbital has always higher energy, and they are written in a pattern like, if say we have a 1s orbital, so it must be like a sigma 1s, and anti-bonding orbital will always written like sigma 1s star. Just I'm taking a 1s orbital example, S only defines the shape, and that one is just energy level. So it is like anti-bonding orbital has always higher energy, and if the energy increases, this will decrease the stability. This will decrease the stability. The stability of so what ultimate is favorable, that the the number of bonding orbital must be greater than that of the number of anti-bonding orbital. If the anti-bonding orbitals are more than that of the bonding orbital, the energy will increase, and more the energy, lesser the stability. But if the bonding orbitals are more than that of the anti-bonding orbital, this will increase the stability. That is first thing. And now we have to look what are the conditions for the orbital to overlap. What are the conditions for orbital to overlap? Condition for orbitals to overlap. We know that according to the VBT, the orbital may overlap head to head, that is axial, head to head, that is axial, and like this is p orbital, and this may overlap head to head, and they are the axial or the orbital, axial or the head to head, head on head. The other one is the side. The another pattern is the side or the lateral, like this. This is the p orbital. Another p orbital come closer, and they interact in the side manner like this. Then now the molecular orbital theory has same status about this, like 2s and the 2s can overlap, like 2p and 2p can overlap, like but 2p and say 2s and 6p it is not allowed to overlap, as the energy level is very different. It means the very first thing that the two of the orbital must have almost same energy, unless or otherwise their overlapping will not be possible. Secondary, they must have the symmetry. For example, if S and S when overlaps, they form sigma bond, and we can see that there is a symmetry. If S and p orbital overlaps, again we can see that they have a symmetry, but nevertheless we can find the overlapping between the P and this P, as they are not in symmetry. What is first thing? That that is the condition of orbital to overlap. The number one, that they must have almost same energy level. Secondary, there must be a symmetry in the orbitals to overlap. And well, the next is we know that the electron in orbit have moves in a wave. So and in a physics there is a wave has a wave maybe when two waves combine together, it may form a constructive और डिस्ट्रक्टिव ऑर्डर. फॉर एग्जाम्पल, अगर हम यहाँ पर एक वेव से एक वेव लेते हैं and the another wave combine with this wave, ultimately if they are in same phase means, as you can see, this is plus and minus, the plus and minus, their phase are same. If the phase are same and they combine together, obviously their amplitude increases, and well, that is called constructive. But if the two of the wave have very different order, this is plus and minus, and the another wave comes like this one, if they are in opposite phase, if they are not in same phase and they are in opposite phase, the result may be destructive, and here the amplitude may go down. And this can be seen in the sound or light or kind of and the wave are in same phase, they form the constructive, and if they are in opposite phase, then this is destructive. The amplitude is going up and amplitude here is going down. That is a first thing, that how the interface actually occurs. This is from the physics. In this, as we know that the electron in the orbit have moves in a wave. So if one of the electron has this constructive phase in the orbital, and this is the one of the orbit, and in the other way, say as we know the wave has the wave function, and here in case we have already seen that this is represented by the psi square, and that psi square is the wave function, and this defines that stability or the probability of the finding electron will be more closer to the nucleus if it is one of our wave, and this combines with other wave of the same phase. This is plus minus, and this combines with the other wave of the same phase, and say it is its wave function is psi b square, and the ultimate wave that formed by the result of these two waves may written as psi a plus psi b and then whole square, as the square as a function. So what ultimate it gives according to the mathematics, psi a square plus psi b square and then plus 2 psi a psi b, and this extra amplitude actually increases, and that extra amplitude increasing means the wave function is increasing, and wave function increases means the probability of finding nucleus closer to the nucleus is more of the molecular orbital. For instance, if we take 1s and 1s2 orbital of the same phase, here the phase can be represented as plus and plus. That is the same thing as we have drawn this plus and minus and plus and plus. It means it is in same phase. when they interact, that is the atomic orbital combines with atomic orbital of the same phase, and here we can see the negative phase are on the other side, they form a orbit or the molecular orbit. And well, that is actually see, this is a sigma s, sigma 1s. And the here this is the molecular orbit. And in case if we take 2p and 2p orbits, 2p and 2p orbital, and when they combine together, when they are in same phase, let's say plus and plus, and the minus remains away, and that is the only representation for the phase. And well, what happens? The electron move, when they combine together, the electron move toward the center, and the final orbital we see will much like this. What does it mean? That the electron toward the electron has ran toward the center, and this form, the plus and minus are still there. So well, we can see the probability of electron toward the center will increase, and this will favor the stability. As the probability to the center increases, this will favor the stability, and hence we know that if they are meeting in the same phase, they are favoring the probability of finding nucleus toward the nucleus, and hence their stability is more. And that is 2p, sigma 2p. That is sigma bond. As we see, they are head on head, and they are axial, so they forming the sigma bond. And let's say if we take the p in the lateral way, that is side wise pattern, and this is again we are representing the same phase, and they construct here, as we know, they are in the lateral phase, there must be a pi bond as they are in the lateral phase, and this one can be also represented as they have to meet in this order. And this is like plus phase comes up and the minus is down, and that will be the nodal plane, and here it is pi bond. So what do we observe, that when the orbitals are of the same phase combining together to form a molecular orbital, the probability increases as the sigma, that psi function, square of psi function increases by 2 psi a and psi b. This extra will increase the amplitude or the psi function, or that is the probability finding to the nucleus, and more they are toward the nucleus means the stability is more, as the interaction between the electron and proton to the center increases. And similarly, in another case, if we combine the orbital with the not on the same phase but the opposite phase, what do we observe? When this is 1s and 1s combines to result into a molecular orbital, that orbit will much like this. It means their tendency toward the center will less, and that is our anti-bonding. And as we know, the anti-bonding has higher the energy, there will be a lesser chance toward the nucleus, and this will weaken our molecular orbit. It means we can take another example of the p and the p. This is say plus and minus, and this is minus and plus, and when they interact to each other, they again forms like this. Here comes the minus, this is minus and this is plus. So their probability toward the nucleus is decreasing as they are away from the nucleus. It means the higher the energy means lesser the stability. So what is the favorable, that the number of the bonding orbital must be greater than the number of anti-bonding orbital, and that will favor the stability. If the number of anti-bonding and bonding becomes equal, that will result to the bond order 0, which means that the molecule does not exist. And number of bonding orbital increase means the favoring the number of bonds, and more the number of bond, higher the strength, higher the bond energy, and the lesser the bond length. So all these features can be measured by their phase, and phase is an important issue while orbital encounter with one another. They must be in same phase. If they are in same phase, their psi function increases, the probability of find electron to the nucleus is more, and toward nucleus means interaction with the nucleus means proton and electron has electrostatic force, so they has higher stability. And